if we look, so if a piece of string was laid out around a circle, and then its length was measured, we would call this measurement the circumference. Essentially, the circumference is just the length of the whole entire circle. What do we know about the measure of a whole entire circle? It's what? 360, that's the measure. That's what it is in degrees. The length is what it is in feet or inches or centimeters, some sort of distance like that. So like if you could take a ruler and measure it, that would the length of the circle be. So it's a little different. And again, that's what we call the circumference. And the formula for circumference is just pi times the diameter, or you'll see it mostly as 2 pi r. If you're given the diameter, it's just easier to use this one. A lot of times we're just given the radius, so this is the one we'll use. Alright, so we want to find the circumference of the circle below, and we like to leave our answers in terms of pi. We're going to do so. We were given the radius, so let's use this equation. Circumference equals 2 pi times the radius. Okay. What is our radius? What is our radius? Our radius is, looking at my diagram, 11. Okay? It's really nice when we leave things in terms of pi, because you don't have to do anything with it. So all you have to do here is just multiply the numbers. What's 2 times 11? 22. And then you just tack on pi. Make sure you label what are the units we're using. Feet. So the length of that circle is 22 pi feet. Again, pi is just 3.14. We'll get a little more into where pi comes from in the next lesson, but just leave it in terms of pi unless it's specified to round. You don't need to worry about plugging it in. There we go. There's the circle. Nice. You just multiply the numbers, stack them. Questions over there? And number 2, it's a little different because we were given the circumference and we need to find the radius and the diameter. So here, when we're trying to find the circumference, we just took the piece and plugged it in and then multiplied. Okay? Well, here, what we have to do is take our circumference, which they said was 8, plug it in for c, and then solve to find our missing piece. Okay. And then we want to find the radius, so that's the piece we are solving for. So that means we want to get the radius for r by itself. So we need to move over the 2, and we need to move over the pi. How are we going to move those over? Really tempting, but you see any plus signs? No. So you can't use subtraction. What operation is it when everything's kind of written next to each other? What is it? Multiplication. So what's the opposite of multiplying? Divide. We're going to divide by 2, and we have to divide by pi. Do the same thing on this side. That way the 2 cancels, the pi cancels, and we're just left with r, our radius. And then we want to simplify this. Well, simplify the fraction. What does 8 over 2 simplify down to? 4. So this just becomes 4 over pi. Okay, and I'll rewrite it so left to right. R is equal to 4 over pi. Let's say we want to know what it is just in case at some point your directions stayed around. To plug this into your calculator. If you have a graphing calculator.
So everyone has a calculator. You have to practice this skill, so make sure you gotta do it. Especially if you borrow one of our calculators. If you need help locating buttons, I'll be around to help you.
Okay. How you're going to type this in a graphing calculator. You'll do 4 divided by pi. To get pi, all you have to do is hit second And then the caret button. It's right above the division sign. A little arrow up button is called a caret button. Hit that and that gives you pi. So again, 4 divided by, hit the second button and then the caret button. And that gives you pi. And then enter. That's about 1.3 is the radius.
Make sure you try this. You can do it on your own calculator.
If you're borrowing one of our calculators, how you would enter it, you would still do 4 divided by. To get pi, you hit the green button, and then you hit the EXP button, which is right above the 7. And that gives you pi. And then you hit equals. Okay? So again, on our calculators, you hit 4 divided by like you normally would. So you hit pi, you hit green button, EXP, which is right above 7, equals. And that you should get about the same number we got here. Okay? Now, we want to know the diameter. What do we know about the relationship between the diameter and the radius? The radius is what of the diameter? So, if we know the radius is 4 over pi, what do we have to do to get the diameter? Times. Multiply it by 2. Okay, well, just like multiplying fractions, this guy is technically over 1. Multiply the tops. 2 times 4 is what? 8. 1 times pi is just pi. And again, just so we know how to do it, go ahead. Again, plug it in your calculator. If you have a graphing calculator, it's 8 divided by second, this caret button. And second caret button gives you pi. And then hit enter. So here it's about 2.5. It's a little off due to rounding. That's okay.
Know both ways, because there may be a test coming up the later of the year. They might have an answer in pi. They may have an answer rounded to the nearest tenth or whatever it may be. So make sure you're aware of how to do both of those. Questions on that?
If it says you generally leave it in terms of pi, we're just showing you how to plug your calculator just in case it asks you to round.
Yep.
So if you just left it as 4 pi, that's fine.
And most of the time it'll say leave in terms of pi. So, that's kind of a blast from the past. You guys have done that before. You found circumference, you found area, things like that. Well, what if we want to find how long a part of it is? We can figure out the distance all the way around a circle, but what if I want to look at just a little piece of the circle? How do I figure that out? Well, I've got an example here. Let's just say the example here is we want to figure out 60 degrees of a circle. 360s all the way around. 60 degrees is just a part of it. Well, how do I do that? Well, I'm going to put the part that I want over the whole circle. In this example, it'd be 60 over 360. We should always reduce our fractions when we can, and that's the same as 1/6. Once we know what that reduced fraction of that arc that I want, I'm then going to, for length, I'm going to multiply by circumference. Sounds kind of confusing, but the formula's not. Look at it. It's really doing the same thing as circumference, but I'm looking for just a little piece, or big piece. I'm looking for a piece of the circle. That's all this is. So the formula that you have to memorize, you will be given the circumference formula, which is 2 pi r, and you will be given the area formula. But for this one, you're not going to have this arc length formula. You have to memorize this, but it's really not that bad. The piece that you want, divided by 360 times circumference. Let's try it out. So we want to determine the length of arc xy. I'm going to highlight that. Here's arc xy. I want to figure out how long it is, not its measure. That is different. Its arc measure will be a degree. Its length will be different. All right. So we're looking for length. The difference. So what is its measure? How many degrees is xy? Do we know it right away? Could we figure it out? Yeah, if I'm saying we can, we most likely can. How much is a circle? 360 is a circle. This part right here is 240. I like it. So we're going to do 360 minus 240. And that will give you what that xy is.
120.
It is 120. So I know this is 120 degrees. Does that mean it's 120 units long? No, it does not mean that. It means that's 120 degrees. To figure out how long it is, we're going to use this formula. So now that we know how the arc is, a lot of times you're given the arc, but this time we had to find it. But we know how to do that. I'm going to put the arc that I want, 120, divided by a circle, 360. It will always, always, always be 360. And we're going to multiply that by circumference, 2 pi r. What's r stand for again? Radius. What's my radius in this example? 15. 15 centimeters. Yep, and I'll put the units on the end. It gets a little confusing there. And the nice thing is, this Baker was talking about, when you see things in terms of pi, Morgan had the question, somebody asked it, well, how do you know it's going to tell you leave in terms of pi? When you see this, it's great. Because, I mean, really, you don't need a calculator. If you got some good mental math, you can solve this without a calculator. A lot of you guys don't know what pi is at the top of your head to the exact number.
3.14569.
You're already wrong. You're already wrong. It's 1415. But 926535890. So there you go. So now what we should do is this. We're going to try to simplify a little bit the best we can. Well, let's break it down right here. And multiplying, I don't know what 2 times pi is off the top of my head, but again, in multiplication, I can do any order. So I can do 2 times 15. You know what 2 times 15 is?
30.
30. So I'm going to keep the outside the same for a second. Again, if you have a calculator, you can simplify this all right away, but I'm going to show you if you don't have one. So I'm going to say that's 30. We're going to treat pi like a variable, meaning I'm going to put the number in front and the pi in the back. Now, I can reduce that as far as it goes, 30 pi. I don't know what that's going to be. I have an idea, I don't know exactly what it is. But I can reduce a fraction, always reduce a fraction. What is 1 over 20, well what's it 120 over 360 reduced to? 1/3, it goes there 3 times. So I'm going to reduce it down to 1/3. 30 pi, there it be. Okay, cool. Well, 1/3. Say, I'm not good with fractions. Why do you say? Well, you're lying. If I cut 30 into 3 sections, what is each section? How long is it? What's 1/3 of 30? 10. So this is my answer. How long is that segment right there? Well, that is 10 pi centimeters right there. That's what that is. Exactly 10 pi centimeters. Does that make sense? No, but that's the exact answer. If we want the approximate answer, you can round. There's no rounding needed right there. That's a nice, clean answer. When do we use that measure? You don't go to the doctor and say you're 1.3 pi feet tall.
Yeah, you do.
That doesn't make sense. The doctor will laugh at you. All right, questions with that? Know that formula. The piece you want, divide by 360 times circumference. All right. Well, let's do a quick little review here of this guy. Area. Area. This takes you back.
That's the old day.
Now, I say it takes you back because when we ask you early year, we do this with most students, we say, all right, what's the circumference formula? Or what's the area formula? Vice versa. Guess what? Most of the time, students switch them up. They get it backwards. Why? They both all the same numbers and variables. They both have a pi. They both have a number 2. They both have a radius. Well, we're talking area, that's square. Think of like when you talk, what's the area of this room? It's the square footage. So there's always a square in that one, being an exponent to the second power. And we only have a pi r squared. The nice thing is, you find out with circles and spheres, you only have one variable. Makes it really easy to solve these things. And that one variable being a radius. We solve that, we have the answer for most of these. All right, let's do a little recap of finding the area of the circle. Leave your answers in terms of pi. Yes, I like that. Makes my math super easy. So what I'm going to do is I'm going to write down the formula. Area is equal to pi r squared. I know what pi is. I know what squared is. What's my radius? 12. So I'm going to say, all right, well, the area is equal to pi 12 squared. Need a calculator? Do it. If not, what's 12 squared? 144. So the area of this circle is 144 pi miles squared. Okay. Yep. It's very large because we're saying the radius is 12 miles. It's a pretty big chunk of area. That's a very large pizza. You probably have like a bite when you get sick. Because well, it's over 24. It's 144 pi miles of pizza. It's ridiculous. Okay, questions? Remember how to do that? Plug it in, solve. Good. Go back. All right, here we go. Write that down. So this next one we're talking about, we talked about on the outside of it. If I have a circle, I would say, I don't know how long that is. All right, you can figure that out. But this is the one that you really care about. This is area of a sector. And I know you're saying, what's a sector? Here's what a sector is. Have any of you guys eaten a slice of cake?
Yep.
Or a slice of pie?
Yes.
Yes. If you didn't say yes, then you're wrong, because everyone's had a piece of pie or cake here some point in time. Now, when you take that out, that piece, that triangular looking piece, is what we call as a sector. So technically, when you ask for a sector of pie, if you want to get technical. Hey, can I have a sector of pie, please?
He's busy on Texas.
I don't get talking Courtney here. So I'm getting a sector of pie. So a sector is that chunk, that part you take out, that's a sector. I want to see how much area that piece of pie takes up. And the formula is exactly the same. The only difference is, instead of finding the circumference, the outside, how long that crust is, if you're thinking, I want to figure out how much area that whole piece takes up. And this is the formula. It's very similar to that. I still want that arc, the measure of the arc that I need, the crust part that takes up, over 360, and I'll multiply by its, the area formula. Again, you'll be given that formula. So let's try this out. A little typo here, I don't know if it's on your paper, but this is going to be sector XOY. So we want to figure out XOY. Just look at it, it looks like this. How much area does that take up?
It takes up area.
Great question, it does take up area. How much, Gary? We'll figure that out. So when we go through here, we know a lot of this piece already. It's the same exact example we did a second ago. So what is the arc measure of XY? How long, or what's the measure of XY? Not how long it is. What's the measure of XY? We found it in the first problem. It is 120, thank you. So this is 120 degrees. We want to find that piece. So we're going to take that, well, 120, divide by 360. And we're going to multiply by it, since we're finding the area of the sector, we're going to multiply by the area formula. Makes sense. If I didn't have this arc measure over 360, that's just finding the area of the whole circle. This just tells me to find a certain piece of it. In this case, this blue piece. All right, well, that's going to be pi r squared. What's my radius here? What's the radius? 15, yeah, it's the same radius we had a second ago. And again, it says leave it towards the pi. So we can simplify this down a little bit. Well, we already know what's 120 over 360 reduced to? 1/3. That already simplified. We do that. And you could have done the fraction first last time. Well, what's 15 squared? 225. And then put that pi in the back. A little harder to think about. But what is 1/3 of 225? 75. So I know that this pi takes up 75 pi centimeters squared. That's its area. 75 pi centimeters. Area is always squared. Include your units. It's very helpful having that. That'll be solved. Questions with those? Not bad. You have to know those formulas though.
Hey, in this last example, we're going to find the circumference area, an arc length, and an area of a sector. So again, what is the formula for circumference?
Yes.
2 pi r. Right? You don't have to memorize this, you'll be given this. Okay? Well, R represents the what? Radius. So what is our radius? So 12, it says leave in terms of pi, which is nice. So when this happens, all you have to do, multiply the numbers. What's 2 times 12? 4. And then tack on pi. So the circumference, the length of this whole entire circle, so if we were to take a ruler and measure the whole entire circle on the outside, it'd be 24 pi inches. So area, what's the formula for area of a circle? R squared. Again, we said our R for this circle was 12. Again, it's nice we leave in terms of pi. So all we have to do is just square 12. 12 squared. 44. Again, just 144, tack on the pi. Our units again are inches, so we write it as inches what? Squared, because we took area. Okay. That's the area of our circle. We then want to find or determine the length of arc AB. Okay, well here is the arc AB. To find the length, we first have to know the measure. What is the measure of arc AB? What is it? 60. Because if we look, whenever the arc's missing, look at the angle. This angle is 60 degrees. And this angle, is it a central angle or inscribed angle? Central, because it's on the center. So whenever it's in the center, the two are the same. So we know that that arc is 60. Okay, well, we do 60 over 360. And what do we multiply that by? What do we multiply by?
What?
Length. You do the angle over 360 times the circumference. Very good, because it's length. Well, what is the circumference of that circle? 24 pi. We just found it. Well, reduce what's 60 over 360? 1 over 6. Very good. So 1/6 of 24 pi, you can leave it in terms of pi. So just do 1/6 times 24, which is what? 4. So it'd be 4 pi inches. Because the whole length on the outside of the circle, the whole length we said was 24 pi. Right? We only want to know this piece of the circle though. We only want to know this guy right here. Well, we know that that is 1/6 of a circle because it's 60 degrees. Well, 1/6 of the whole circumference is 4 pi. Really similar to find the area. Same thing. You take the measure of the arc, which we already said was 60. Put it over the whole circle, which is 360. But instead, when it's area of a sector, what are we multiplying it by? Pi r squared, the area of the circle. Well, what did we figure out the area of the circle was? 144 pi. When we simplify this, we already figured that one out. It's 1/6. What's 1/6 times 144? What is it? Someone said it. Very quietly. Very good. 24. Pi, again, is area, so it's inches squared. Okay, again, the whole area of the circle is 144 pi inches. Okay, we just want to know a piece. We just want to know this orange piece right here. Well, that orange piece is 1/6 of the circle. So 1/6 of the whole area is 24 pi. And you'll be given these formulas. You're not going to be given these, but you just have to remember, put the arc over 360 multiplied by the circumference. Put the arc over 360 multiplied by the area. And you'll be given those area and circumference formulas. Questions over that? Okay, rest of the time is yours. Work on the practice. If you have questions, happy to answer them. We'll have extra practice with this tomorrow. Quiz over this on Thursday. Start reviewing for your test on Friday.